Hello guys and welcome to the third part of the Procedural Microchip tutorial series. No big talks in the intro today, let's get right down to work and continue where we finished last time so we can get home early. So what's the plan for today? We have to distribute the pins on the capsule, then make cutouts for the pins and mix and assign the materials to both the pin and the capsule. Those are the 3 tasks that have to be finished until the end of the shift. Let's not waste any more time, here we go. Let's distribute the pins. I will separate the connection from the pin because we don't need that right at the moment, and actually connect the capsule here through a join geometry node to the group output. Another thing that I will do is add a mesh line here that will serve as a source of points where I will place the pins. The mesh line will be placed on the side of the capsule, and we have to set the parameters of this node. So let's add here a group input with the parameters of the chip. For the count of points of the mesh line, we have to halve the pin count. So let's multiply it by 0.5 and enter the value to the count. Let's zoom out so we see the line. The start location and offset, we have to enter here a combine XYZ nodes to both of the sockets. So let's duplicate it and connect it to the offset. Well, the line disappeared, so let's keep here the offset at 1 for the moment, and let's calculate the start location. So the start location on the x-axis will be chip width multiplied by 0.5. We will be multiplying by 0.5 a lot this time. So let's plug it here on the x-axis. Now for the start location on the y-axis, we have to take the half value of the pin count, subtract 1 from it, as there are always 1 less spaces than there are number of points on the mesh line. So let's subtract 1 from this halved value, then multiply it again by the pin distance. So let's plug the pin distance and the subtracted value, or the resolution of the subtraction. And when you plug it into the y-axis, it's too far. We actually have to multiply it again by 0.5. So let's fix that. 0.5 and plug it into the y-axis. Then obviously we don't want the mesh line to be on the z-axis, so let's zero that out. And the offset is actually the offset or distance between individual points, so that is straight our pin distance, and we can plug it into the y-axis. Well, it's still positioned wrongly because we need to translate it on the negative direction of y-axis, and we can either multiply it completely by -1 or simply introduce the sign to the 0.5 value, and that will fix it for us. So now we have the source of points completed, and we can actually add here the instance on points node. So let's add here. The mesh line will be the source of the points. I can already separate the connection into the join geometry. The pins actually will be the instance. Let's move it here, and well, let's plug it into the join geometry. Well, we have them where we want, but I see some problems. First one is the pins are completely inside the capsule, so to fix that, I will actually use the translation of the initial arc that we made for the pin, and I'll move it with 0.4 millimeters on the x-axis. That fixed the position. Okay, the second problem here is the shading, or that it's missing bevels actually. And that's because the bevels do not work on instances. So what we have to do is add a realize instances nodes and enter it on the output of the instances. So that will realize it into a geometry, and the bevel can be applied. Third problem here is the shading. While the pins are, the bevels are shade smoothed, the bevels on the capsule are shaded flat. Well, it actually turns out that it matters in which order you plug the outputs into the join geometry. So if you separate the connection from the capsule and plug it below the pins, that will fix the shading. So it's nice to know. Okay, and the fourth problem here is that we don't have the pins on the other side. So to fix that, I will duplicate the join geometry node, the realized instances, and these two nodes, I will move them to the side. And I will add here also a transform geometry node, and actually take the instances from this side, pass them through the transform geometry, introduce a scale on the x-axis of -1, which will actually mirror it, and then simply join the two instances together and pass them through the realized instances, which will place it on the other side as well. Now, also one final touch-up I want to do is to introduce a bit of a randomness to create an illusion of bent pins, and I will use it with a scale instances node, and plug it after the join geometry. Then draw out a random value from the scale. So add here a random value that will automatically change it to vector. And obviously that's all wrong. We don't want the minimum on Z and Y axis, or we don't want the scale to happen on Z and Y axis. So let's introduce a minimum of 1 to both of these axes. And for the minimum of the scale on the x-axis, let's try something like 0.8. And that should create the illusion that the pins are not really in a straight line. Maybe it will be better visible if I change the pin count to something like 24. And yes, that will create a bit of a randomness here. Maybe change the value to 0.85, so it's not that harsh. Yeah, it's a new chip. It's not some old used chip. Okay. We could actually introduce the random value also here in the scale of the instances of points. The problem is here that we are mirroring it, and the randomness would hurt. It wouldn't be a randomness because it would be mirrored in the same way to the other side. So what I want to do is actually take all the instances when they are mirrored and then apply the random value. What I don't like about this is the way the pin enters the capsule. It's somewhat boring. It needs something, and that something would be to add a cube that will be subtracted from the capsule and create a hole for where the pin enters the capsule. I will reuse the mesh line that I used for the distribution of the pins and distribute cubes along it that will be subtracted from the capsule. So let's select the mesh line, including all the calculations that we made for it, and hit Ctrl G to make a group out of it. The inputs got all these names from the values that they are plugged in, so let's take care of it. The Y input is actually the pins distance. The second input is the pin count. Okay, it's a type of integer, so let's keep it. And the last one is actually the chip width, and that's a float. Okay, let's move one level up, and in the node, in the properties, let's name this a pins distribution line. Okay, so we have the groups that we created organized. Now let's duplicate these two nodes. So Ctrl C, and I will put it somewhere above the capsule. So let's plug it here. Okay, and what we need to do is add a cube node, and we need to set the size of the cube. Let's just hide the side panel actually and return the view here. Okay, let's plug in here a viewer, and obviously we have to set the scale for it. So let's add here a combine XYZ node, and X scale will be the chip width. So let's plug it directly. And the size, let's disable the viewer. The size on the y-axis and on the z-axis will be the same as for the pin. Well, so let's go to the pin and actually add here the group input node and take the values from the width of the quadrilateral profile and the height of it that we used for the extrusion along the arc. So let's plug here the height and the width and the height. Now again, unhide the side panel, go to the group and rename it as a pin width and pin thickness. And hide them in the modifier tab because the user doesn't need to get to this value. So now let's hide the side panel and return here and simply plug the width to the y-axis and the pin thickness to the z-axis. Enable it, and that's exactly the dimension we want. We just don't have the correct position because I will be placing it here and I want it to go through the chip. So we need to translate it. Let's add here a translate node, transform geometry node, and use the translation. So add here a combine XYZ, and we will just need to modify the position on the x-axis with 1/2 of chip width. So let's multiply this by 0.5, and actually I think we have to transform it on a negative x-axis, so let's enter here minus 0.5. Now we can distribute it along the mesh line, so let's add here the instance on points. Where do we have it? Here it is. Plug it right here, except it's plugged wrong, so let's plug the cube on as the instance and the mesh as the source of the points. That will work right out. And now what we can do is simply plug the instances into the mesh2 socket of the mesh boolean. Now we can disable the viewer, and actually nothing happened, or something happened. The boolean the bevel is not shown again. That's because the cutout parts are quite small, and we have to, in the geometry, disable the clamp overlap, and that will work again. Now what I want to do is actually to enlarge that cutout just a little bit. So I will add here a vector math node and plug it after the combine XYZ. Keep that as an addition and add a very tiny value to all three components of the vector. So that will be 0.025 millimeters. So let's duplicate that. Control C, Control V. We actually don't need to add pretty much anything on the x-axis. That's really not necessary. Well, we can add here something actually. Let's add here a value of 1 millimeter. That should be more than enough. Okay, let's keep it like that on the x-axis because it's the width of it, and let's just make sure that it's a little bit wider than the capsule. Let's get rid of the viewer node, select all of them, and in the node wrangler, frame select it, and name this as pins cutout. And do the same for the distribution. So again, select all the nodes. Let's just move them a bit closer together. Click frame select it, and name this as pins distribution. Okay, and also I want to make the material selectable in the modifier tab. So I will enable the material socket in the group input that we already have here, move it a little bit downwards so the line doesn't cross the other nodes. Now actually let's name this material as material pins. And I will do the same here in the capsule. So let's add here a set material, plug it after the set shade smooth, and again drag out the material socket into the empty socket of the group input. move it downwards, and again also move downwards the said material so the line doesn't cross the other nodes. Also move the pins group somewhere closer here. The pins distribution I think I will place here, and the pins cutout somewhere here. So we have it all nice and tidy. One last thing I want to address here in the modifier tab is the pin count entry field. Since we can enter an odd number here, we are multiplying it by 0.5, and that will kind of mess up the alignment of the mesh line and the capsule, as we are getting a non-integer number as the result. So to get rid of that, we will simply use another math node set to truncate, which effectively cuts off the decimal points after an integer value. So let's actually plug it here between the multiplication and the subtraction. That's for the mesh line. And we will do the same thing here at the capsule, where we are calculating the length from the half pin count value. So let's duplicate the math node and simply replug it. Also, don't forget to set it to truncation. Instead of the truncation, you could also use a rounding, which is rounding it up to the next integer value. It will work pretty much the same, except for here the pin count in this case is the same thing as 22, while if you use rounding, 23 would be the same as 24. After the shading tab we go. Let's zoom out a little bit. Go to the modifier tab here and duplicate this material. Let's name it as a capsule and assign it to the material here. What I see that we didn't name it properly, so let's fix that. Let's name this material capsule. And now back to the shading tab. Also, let's return to the metallic material. Let's name it metallic pins. Now, let's start with that material and add a noise texture here. Plug the vector socket into the texture coordinate node, texture coordinate, and into the object socket. Now, the factor will go into a bump map, into the height socket, and the normal will plug into the normal socket of the BSDF material. That will create just a tiny bump map. Now the scale is too large, so it pretty much screwed up the normals. So let's fix that. The scale here has to be something big, like 100,000. Okay, now we have the scale probably correct, and we just need to tune the noise texture. So let's decrease the detail to 1, roughness turn all the way to 1. That will create a sharper transitions between the black and white color, and the distortion here, that will create kind of swirls. Let's increase it to 0.25. Now for the bump node here, we obviously need to decrease both the distance and the strength. The distance will be at 0.01 millimeters and the strength at 0.01 or maybe 0.1. Now that's too much. I think at 0.01. I want it just to be a very, very subtle. Okay, so I will also use this noise texture for the base color, but I will pass it through a map range node. Since it goes all the way from black to white, I will want it to make it a little bit more gray, not both the extremes. So the minimum value instead of black will be at 0.3, while the maximum will be at 0.49. That will go from gray to gray, and plug it into the base color. That will sort of amplify the effect of the bump map by creating darker spots in the valleys of the bump map. And now finally for a roughness texture, I will duplicate the noise texture, reconnect the vector socket here, change the scale to 750, and let's plug it directly to the roughness socket. First of all, I want to invert the textures, so these these rough parts are actually shiny instead of rough. and the rest will be sort of like a fingerprints or a grease layer on the metallic material, so they will be a little bit more rough. So let's duplicate the map range node and plug it on the line to the roughness socket, and let's actually set it up. So the it will go from 0.35 for the rougher spots to 0.15 at the shinier spots, and I think that can stay like that. Now let's go to the capsule, and again we will start with a noise texture. Maybe we could turn down the metallic value and actually increase the roughness to something like 0.6. The base color, I will turn it to black for the moment, and the vector from the noise texture again plug to the texture coordinate node and from the object socket. Pass it again through a bump map, through the height parameter, and plug the normal into the normal socket of the material. Now again we have the scale all wrong, so we have to adjust that. And the value for this one will be 50,000. The detail, I'll keep it here at 2. The roughness will go again all the way to 1. And distortion, just a tiny bit, 0.1. Now, for the strength of the bump map, the strength for the moment I will keep at 1. And let's take a look at the distance. If we decrease it to 0.01, that might be what I'm after. I think that can stay like that. Okay, so I will use the noise texture also for the base color, but this time I will pass it through a color ramp. Okay, plug the vector into the base color, and I will go with a value of 0.02 for the moment for both of the ends. So 0.02, that will create a plain color. And now I will add a stop here, somewhere at the position of 0.72, and what I want to do is create some lighter spots like speckles on the peaks of the bump map. So let's turn the color to something brighter like 0.6, and what I will need to do is add the additional positions or stops here and change the value like it is at the first stop and the last stop to 0.02, and make that push it closer to the brighter stop here, and again duplicate it and also limit it from the other side. Now also change the interpolation mode to cardinal, and by moving the sliders we can influence how many brighter spots there are on the capsule. I think I will keep it like that, maybe decrease it a little bit. And I think that is the sweet spot that I was after. Now for the roughness, let's use the same noise texture and just pass it through a map range node into the value circuit, plug in the result into the roughness, and just set up the values to min and to max. And min will go here from 0.65 to maximum of 0.35. And that's where we will wrap it for today. In the next part we'll take a look on how to make a window on top of the microchip, so in the part after the next part we can place there a beautiful piece of silicon. But let's not get ahead of ourselves. Stay tuned and make sure to hit that subscribe button so you don't miss any of the upcoming parts of the series. See you at the next video.